chosen death.
Hello folks, Reginald Scott here, and welcome to this very special video. I thought Hambini would take this with good grace when I proved him wrong, and I thought he would admit his actual factual mistake and we would just get on with our lives. But unfortunately he chose not to. Instead, he acted in a disingenuous manner, and he chose to even ignore the factual thing that he actually got wrong. What was so bad about his video? It was the amount of stuff that he did to mislead his audience. He literally made stuff up. I mean, you might say that Hambini's video was the greatest work of fiction since a guy called Homer put pen to paper and wrote the Iliad. For example, his schematic that he drew, his little technical drawing, was so full of factual holes, which I will be poking in it later, that you could market it as a new type of French cheese. I said French, not Swiss, which is more famous for the holes, because Hambini constantly says that he's French. He also constantly says he's 5. So what does he say that we can actually believe? I don't know, not anymore. Now, not all of you were fooled by Hambini, which was very gratifying to know. Like this gentleman over here, he noticed one of Hambini's sleight of hand trickery straight away to mislead the public. I mean, this gentleman as well was also not fooled. So there you go. So I'm really glad that there was people out there who didn't eat the dish that Hambini was serving. But what's interesting to me is that in the comments section on my video, so many of them came and descended like locusts to write comments saying that I was wrong and using talking points that Hambini had used in his video, which are easily refuted, easily, with facts, if you have actually watched my original video. And what strikes me as amazing is so many of them haven't. But not just that, I've got more evidence that the Hambini fan club, the Hambini catamites and cultists that follow him around and hang on to his every word as the part of cult of Hambini, they don't actually watch my video, and so they are making all of their statements and constructing all of their beliefs on false information and only one side of the argument. Like this gentleman over here, who blatantly states that he didn't watch my video, but he concluded I was wrong. I'm laughing, but that kind of person is the most dangerous person on the planet. These are the kind of people you get to guard the camps, because they don't ask questions and they just do what they're told. A real member of the Hambini cult. But not just that, there was varying degrees as well. And I found this really fascinating. So this gentleman, I'm assuming his gender, but gentleman, whatever, he has some mechanical knowledge and he actually started to question Hambini. Oh, good Lord, no. He almost broke the programming. He almost got out of the cult of Hambini. But Hambini, after watching Hambini's video and digesting the falsehoods that Hambini produced, he did a 180 and went back. Now, I really hope this guy is watching this video now. And if he is, please do, after the video, do comment, because I'd love to hear from you. I'm going to rescue you, dude. I'm going to rescue you from the cult of Hambini and prove that your initial thought was correct. You were right. Your gut feeling, your instinct was right. Hambini was fibbing to you. So there we go. So I hope I can save people like that today. And then there's this one, which is also interesting. Guy asks a perfectly legitimate question and he wants a perfectly legitimate answer. What he gets is not an answer to his actual question. What he gets is a lie. Hambini shuts his independent thinking down with a lie. Why do I say that's a lie? Well, Hambini watched my video. He did, because he took clips from it. Hambini knows that statement is untrue because he watched my video. So I would consider that a lie. If you actually watch the video, you'll see me place the bearing puller on this ring here, which is in more towards the center of the hub. And people also accuse me of damaging the face of the hub, saying that by placing the legs against the face of the hub that I would dent or deform the front. Well, I'm running my finger around it right now, and I can tell you there's nothing. There's not a chip, not a scratch, not a dent, not any kind of deformation to the face of the hub from the puller whatsoever. But in today's pull, we have an addition, which is this, a washer, steel washer that says 304 on it. Yeah, I do know what that means. This steel washer is very thick, as you can see, and this is not going to bend at all. And what you do is I put a little bit of electrical tape on the back, and I'm going to place that on top so it doesn't scratch the hub. And I'm going to place my puller on top of that very strong steel washer, and that's going to give me a lovely platform to pull against. And this was suggested by many people in the comments, so thank you very much for that suggestion. So the first thing you'll notice is that he's doing multiple hits in one location. Now, you should never do that. You should hit and move, hit and move. That way you don't overdrive the bearing in one place, and you don't run the risk of getting the bearing wedged or jammed, because the more times you hit in one location, the more the bearing twists. You don't want to do that. Second thing is the amount of hits. I counted roughly 40 hits to remove that bearing. I don't know why on earth it was taking him so many hits to get that bearing out. If the bearing was jammed in there because of corrosion or something, it's only making the situation worse by driving away at it with a big hammer. And mentioning the big hammer, we come back to the lump hammer or copper hammer that he's using. That thing is significantly too big for this job, but it's also too heavy. That thing probably weighs 2 to 3 pounds, maybe even more than that. My father has one, and he uses it for hitting rather large pieces of industrial machinery, not tiny little wheel bearings seated in a little aluminium hub. So all in all, poor technique, poor choice of tools, and generally just hitting the thing too many times and too hard. I will now demonstrate how it's done. So what I have here is a windspace hub that was a warranty return. And what I've done is I've removed the axle, which is usually used for driving the bearings out of this type of hub. And what I've done is I've pressed back the bearings into this hub. By the way, this hub will never be used in anybody's wheels, so it's perfectly safe for me to mess it up. And by doing that, I've given myself a scenario similar to that of what Hambini has in his video. This bearing is right at the surface, and this one is about double bearing depth down. So I'm going to try and strike this one out first because it's the harder one to do. And by putting both bearings in, I've also made my life more difficult because I have to go in at an angle. So I'm putting it on a hard, flat surface, so it's actually better to spread the load really evenly on a hard surface like this than it is actually to use something really thick and soft. Also, the thick and soft surface dampens the blows directly to the bearing, so it actually ends up taking you longer to get the bearing out. Let's see how fast I can get this bottom one out. I have to go in at an angle. 1, 2, 3. I'm moving the punch every time. 4, it's actually a threaded rod, but I don't have a punch this thick. 5, because I don't do this job. 6, 7, 8, I just hope I beat the target of 40. 9, 10, 11, 12. Okay, so it might have been 11, but I checked at 12 and it fell out. So there you go, 12 for that one. And then the front one, which will be a lot easier now because I can get my rod directly down the side of the hub. It's a lot easier when you only have one bearing. 1, 2, 3. So this is what I'm saying about technique. Like I say, I counted at least 40 hits with Hambini and they sounded pretty hard. But if you consider how big his hammer was in compared to mine, you know, and I'm not jealous or anything.
Because it's just the right size.
It's not the size that counts, it's how you use it.
I'm using quite a small hammer, so my hits when I choke up on the handle are not that hard. There's not much weight here. If you're using like a big copper mallet, every hit is going to be really hard. You're really going to have to control your hits, and if you do hard hits, then you're going to twist the bearing even more. Hambini asked me to explain myself, and so I did by citing all the disadvantages of the hammer and punch method, and then saying that good bike shops usually use drifts made by the manufacturer, bearing pullers or bearing presses to remove bearings from wheels. Hambini reiterated his issue with the preload tube, and then stated that he couldn't think of any other method to get that bearing out. He mentioned to another commenter that the preload tube is problematic. I said problematic yes, but impossible no. I have a bearing puller that would work on that. I've done it several times in the past. It's really not an issue. Hambini asked me to make a video of the puller, and so I did. Hambini came to my video and stated, "Your blind bearing puller that you show won't work on that wheel you referenced. You still need a gap behind and the preload collar is in the way." I attempted to educate the aerospace engineer on the intricacies of bearing pullers, but I failed. Hambini continued to comment in a somewhat condescending manner, trying to explain something to me that I actually knew better than him. But it was too late. Hambini's fate was sealed. The moment my bearing puller removed the bearing from the wheel without complication, Hambini was proved irrefutably wrong. So if you're Hambini, how do you win an argument that you've already lost? Well, it's very simple. You ignore that original argument and you come up with a new argument under different parameters, ones which you think you can win on. And that's exactly what Hambini does. What he does is take our original argument, which was I said that using a hammer and punch to dismount a bearing from a hunt hub was damaging to the hub, and therefore using a bearing puller would be a better method, and he said the bearing puller wouldn't work, and I proved him wrong. He's taken that and extrapolated it to, I am saying that using a hammer under any circumstances in any industry to dismount any bearing is wrong. I never said that. I never even insinuated that. I never claimed that. But that is what he wants to argue on because he thinks he can win that one. And what he's going to do is talk about all these companies which use hammers in their dismounting of bearings and make a false equivalency between what he did, which is hammer and punch, and what they do. The only problem is what they do often doesn't lead to damage to the item they're working on, whereas a hammer and punch does. So he's using a false equivalency, he's being disingenuous, and he's not arguing the original point.
Who else got it wrong? Well, there's me and a few other people. We've got these brands.
How do you do? My name is Bessie Bellwood.
Liar!
Oh, you don't fool around, do you?
Let's look at SKF, one of the world's largest bearing manufacturers, and see if they dismount bearings in the same way as Hambini does. Acorn Industrial, a leading supplier for SKF in the UK, says if you don't have any specialist tools around, it could be tempting to use a hammer and brute force to remove the bearing. However, this can lead to surrounding components becoming damaged, causing further downtime. A bearing puller can efficiently remove the stuck component from the shaft or recess without causing any damage to the shaft or surrounding components. This helps to promote the uptime and reliability of your machinery. Bearing pullers also offer a safe method of removal when compared to techniques such as brute force or naked flames. Leading manufacturers such as what? SKF? Have optimized puller design to ensure that they enable maximum worker safety? Hang on a minute, I thought Hambini was suggesting that SKF do his method. I am shocked. Are you trying to tell me that SKF manufacture bearing pullers? That might be why I found 120 different kinds of SKF branded bearing pullers on that one website alone. And I would also say that during my extensive searching, I found not one set of hammer and punches manufactured for the removal of bearings made by SKF. SKF do not sell a hammer and punch set. The only thing they sell, which even comes close to a hammer and punch set, is a device that they've designed for mounting bearings on shafts, which is this. All other systems they use are pullers and hydraulic pullers, which are really cool when you have a look at them.
The SKF internal bearing puller kits are designed for dismounting bearings from housings, where the fit is on the outer ring. The TMIC series has an expandable collet design made of high-strength steel and is designed for applications where there is a limited space to grip behind the bearing.
Huh, limited space behind the bearing, you say? I wonder what applications that could be used for. So this example in the top right hand corner of the screen, which Hambini uses, is a cold dismounting from an industrial machine. This machine has a large axle with a tapered adapter and a very large industrial bearing on it. This one's considered small by SKF, but small to them is 80 millimeters across, so about the size of my fist. And this thing is being tapped off the mounting with a integrated drift that comes with the machine, by the look of it. And when I tracked this down, it was quite difficult to track down. What I found was quite interesting. It actually backs up my argument, not Hambini's. It clearly states that a small bearing, which is this one, can be dismounted from a shaft by applying light hammer blows via a suitable drift, not a punch, but an integrated and designed drift, to the ringside face, or preferably by using a mechanical puller. So it's clear from this that SKF want you to use a mechanical puller, not the hammer. In the same section we read, the choice of tools depends on the bearing type, size and fit. SKF methods and tools. If you click on that, what you find is a detailed diagram showing you all the preferred SKF dismounting methods. Basically, all of them are bearing pullers of different kinds. The only one that isn't a bearing puller is that tool that I showed you earlier for mounting bearings onto shafts. So there you go. SKF do not endorse hitting something with a hammer and a punch. They don't even endorse hitting things directly with a hammer. What they want you to do is use bearing pullers.
And he posted a video with this handsome chap.
I also fact-checked Hambini's claim of being handsome by asking my wife. She said no so fast I didn't even finish my sentence. And by the way, she has no idea who Hambini is. I just showed her a picture. So sorry, Hambini, fact-check false on that one, because my wife is always right. Okay, let's move on to looking at how Zip and DT Swiss dismount their bearings from their hubs. So now I'm going to show you the DT Swiss system for removing bearings from a hub. And what I absolutely love about their system is it's very simple and it's very safe. So you've got the axle. The axle has got two lips on it behind each bearing, right? So when we strike here, in theory, the other bearing should come out. And what's interesting is it will come out straight because it's guided by the walls of the hub and by the axle, okay? Unlike if you hit it with a pin punch and hammer, it can come out any which way. It can come out at a weird angle, right? Can't happen with this system. And the way you make it extra safe, or the way DT Swiss make it extra safe, which is superior to a lot of the other systems out there who just literally get a soft hammer or soft mallet and strike directly on the axle. DT Swiss are like, no, come on, we're Swiss, we don't do things like that. What we do is we machine a beautiful axle protector like this to prevent you from missing or bending the axle. And then they have this insert here, which is a soft aluminium insert that goes in the top. And instead of damaging the top of the axle, you hit against that. So what we have is a totally protected system whereby the bearing comes out straight and you have minimal risk to the hub. Like that. One strike and everything pops out. And then here's the really good part. You take your bearing, you slide it off the axle because the machining is fantastic. You take your axle and you put it back in the opposite way round. So now you can drive out the other bearing. But aha, I hear you say, this is no longer supported by a bearing. So what's stopping this axle bending and driving that other bearing out at a funny angle? This. The axle protector. The axle protector is exactly the same diameter as the bearing, so it actually fits inside the hub where the bearing used to be, making it completely solid and completely unbendable. Axle protector goes in top and you hit it again. and it drives out the bearing perfectly straight. It is a wonderful, wonderful system. So we can see that the zip system in the example given by Hambini is virtually identical to that of DT Swiss. It uses a soft hammer to direct force against the axle to drive the bearings out of the hub in a straight line. Unlike the hammer and punch method, which uses a metal punch to hammer out the bearing at various different angles from the hub. One method will damage your hub, one method will not. This is yet another argument of false equivalency from Hambini. He's trying to compare two things which are simply not the same. They're not even the same hub type. I'm going to show you a bearing removal video from Industry 9, the MTB specific hub manufacturer, and they do it in the same way, and I'm just demonstrating that if you have this hub type, this system will work. Okay, so I'm now going to show you the Hope Hub company from the UK that Hambini listed on his video. And these guys actually do use a punch in the dismantling of their hubs, or to remove bearings from their hubs, which is funny to me because they don't need to. And I'll tell you what I'm talking about in a second. So here we are with our nice young mechanic called Dan. And if you notice on the right hand side of his desk there, he has some aluminium tools that look very similar to the DT Swiss ones. And they basically perform 50% of the same job. What they are is the pressers to press the bearings back into the hub. But there's actually no reason why you can't use those in the same way as DT Swiss do. And I'll get on to why I'm saying that in a moment. Anyway, he also has his small mallet with the rubber end and his punchers. Notice how thick that axle is. That is a really beefy axle. No problem at all with hitting the axle with a soft mallet. You're not going to do any harm to that. It's pretty thick gauge aluminium. Anyway, he places it on this special hub protector, which is got a nylon bushing on it. And then he takes the rubber mallet and he taps on the axle and pops one side of the bearing out. Absolutely fantastic. Well done. Brilliant. Right, now, DT Swiss, Zip, Industry 9, all the other ones we've looked at would just turn that axle around, put it back in the hub, and tap it again, wouldn't they, to knock the bearing out. But Hope, they don't do that. What they do is use a punch to hammer out the next bearing, which doesn't make any logical sense to me, because on the desk there, he has two tools to do that job, remove the second bearing, which are better for the job than the punch. The punch is going to knock the bearing out at a weird angle. If you put the axle back in the hub and then you slide over the bearing press drift, which is on the desk there, the tall one, the tall thick aluminium drift, if you slide that over and then tap with the rubber mallet again on the top of the axle, it will remove the bearing in a straight line and not damage the hub. But instead of doing the thing that all the other manufacturers with that hub design do, which makes logical sense, he takes a punch and he ends up hitting it 3 times to knock the bearing out, which means the bearing must have twisted at least twice on exiting the hub, which will have caused some level of wear or damage to the hub.
Once again, check that for any damage. Once again, check that for any damage.
Some people argue that I should always follow the manufacturer's recommendations on tools when I dismantle a hub. One of the arguments against me using a bearing puller is, oh well, the manufacturer suggested that you should use a punch and a hammer. Just because a manufacturer suggests something doesn't make it the best way to do it. It also doesn't make it the least damaging way to remove the bearing. We can clearly see in this example that Hope used a tool they did not need to use that actually increased the likelihood of damage to the hub. If you compare this with the Industry 9 method, or the Zip method, or the DT Swiss method, you can clearly see that using a punch and hammer is inferior to what Hope could have done. Manufacturers are not always the best judge of what tools should be used in the maintenance of their products. There may be aftermarket solutions which are better or even superior to that of the ones suggested by the manufacturer. I'll give you an example. This tool here is used by DT Swiss to dismount the star nut from their hubs, their 240 hubs, for example. Now, this tool is designed to be placed into a vise, and then you're supposed to place the wheel on top and turn the wheel in the vise to remove the star nut. And often this leads to damage to your vise. In fact, I have broken 2 vices using this tool. Now, this tool is made by a guy on Instagram who runs a page dedicated to bike mechanics and beautiful bike tools. And they have made this aftermarket tool, which does the same job as the DT Swiss tool, but instead uses a different kind of key on the back, which allows you to use it in an impact driver or in a socket set, which A, means you don't break your vise anymore, and B, makes removal of the star nut much easier and much simpler. This is a clear demonstration that manufacturers do not always possess or know what the best tools for the job are. Often, bike mechanics will possess specialist tools which are better for doing the same job. To illustrate my point further, I contacted Hunt directly and asked them very clearly if they had any objection to me using a bearing puller on their hubs with the preload tube. They, of course, said no, not at all. They had no issue with me using my bearing puller. I asked them also why they use a hammer and punch method, and they said it's simple and it's easy. Manufacturers prioritize speed and cost saving when they make their decisions. That is why they give their staff hammer and punch sets. Those hammer and punch sets are cheaper to buy, they are easier to train people how to use, and they dismount bearings very quickly. They do, however, cause damage and run the risk of serious damage. A bearing puller does not. However, to the manufacturer, the bearing puller has some major disadvantages. It's more expensive to buy. It takes longer to train their staff how to use it, and it takes longer to pull the bearing out of the hub. It might do a better job, and it might protect the hub much better than a hammer and punch, but to the manufacturer, those factors are unimportant. Another reason why the manufacturer may suggest to use a hammer and punch during maintenance is because they are catering for the lowest common denominator, being you at home. You at home are very unlikely to have a bearing puller like me. You are likely to have a hammer and a screwdriver, or a large rock and a piece of dowel. So therefore you can do maintenance at home with those simple objects. The manufacturer knows this. There is no point for the manufacturer to write a manual on how to pull bearings from their hubs with a complicated bearing puller when they know you aren't going to have one. The majority of Hambini's argument hinges on discrediting my bearing puller as being a legitimate way to remove bearings from a Hunt-style hub. And Hambini attempts to do this by saying that my bearing puller will damage the preload tube within the hub. This is false. What Hambini does is he clips my original video to prevent you from seeing an important piece of evidence that would absolutely destroy his forthcoming argument. He clips it here and then moves on to his drawing, which gives a totally misleading and false impression of what actually happens inside the hub. We'll look at that in a moment, but let's first look at what you missed, what that important piece of information that Hambini prevented you from seeing was. And there we have it. There is the bearing, and there is the teeth, and if you look, it's almost completely flush with the inside of the bearing there, and that is because those teeth are shaped to fit in the little chamfer, in that little recess behind the bearing. Isn't that brilliant engineering? It's almost as if somebody designed it that way.
So I've drawn a schematic of what is going on in the scenario you've just seen.
Liar!
So on the right hand side is what you would get in a typical setup.
Liar!
So this one here. On the left hand side, I've drawn a diagram of what Reginald claims he has in his setup.
Liar!
The only real difference is this chamfer here.
Liar!
So the first problem with Hambini's schematic is if you notice at the red arrow I've put there, there is no chamfer, or as Hambini refers to it, radius on the bearing. That is a gap or a machined part of the bearing in which the bearing puller rests when you place it inside the hub. he's totally taken it out of the picture. So he's not even representing me accurately, because that is not like my original drawing, as you can see. Then at the blue arrow, which is what he claims is going on, he doesn't put any machining on the tube, which is fine if that's what he wants to do. But he also doesn't put any machining or chamfer or radius or whatever he wants to call it on the bearing. So he's erasing the gap from both sides of the drawing, as if it doesn't exist at all, which it does. And we know it exists because we hear our bearing puller snap into place in my original video. Do you hear that? That little ting? That is now perfectly gripping. I can't even pull that out. That is gripping just behind that bearing now. It wouldn't be able to snap into anything if there was no gap there. Also, he's made the bearing puller far too chunky. He's represented it kind of chisel shaped, whereas in reality the bearing puller's claws are much finer and much more rounded than that. Next, Hambini represents the bearing puller going inside the preload tube. This in reality never happens because the legs of the bearing puller are sprung loaded, and once they reach the recess behind the bearing, which is the chamfer and or radius, they snap into position above the preload tube. Interfaces with the bearing flush like this, so that the tube that comes out in the middle, as you can see, the puller doesn't go inside the tube. The puller sits inside the bearing, flush, behind the tube. So the tube doesn't come in contact with the teeth of the puller. The drawing that Hambini made is false. It doesn't exist in reality.
It's false. No way. Not this time. We created it. Not this time. No, not this time. It's totally made up. Pure fiction. It's fiction. It's fiction. We made it up. We made this one up. It's a made-up tale. It's a total fabrication. It never happened. It never happened.
Now the method shown in that Reginald video, it requires a bearing with a large radius, basically an enduro style bearing.
Liar!
You also need a preload tube with a chamfer.
Liar!
On the right, you've got a wheel bearing, which I've done the blind bearing puller up a quarter turn past, locked up with a couple of spanners, and you can see how much that sticks out, hence the damage to the spacer.
Liar!
Hambini appears to be attempting the world record in how many lies you can tell in 30 seconds. Unfortunately, he just failed to meet the target for a world record, but he did make a very valiant attempt. Let's look at each one of these lies in turn. So the first one is he's saying this only works with enduro bearings. Well, unless everybody he's talking to is blind, I think you can see quite clearly that the bearing that I pulled from the hub is not an enduro style bearing. It's a standard wheel bearing you'll find in virtually every kind of wheel on the market. The bearings that I buy for the shop are not enduro bearings, and the puller works perfectly on those. And I have pulled bearings over the last 5 or 6 years with that puller out of wheels of almost every brand, whether it be Mavic to Fast Forward or DT Swiss to Fulcrum, and it's worked every single time. So a blatant barefaced lie there. The second lie is that it requires a tube with a chamfer. That's also not true. Again, you can clearly see here that this tube is not really chamfered, but it actually doesn't need a chamfer to work. The recess in the back of the bearing is more than enough for the puller. And the final lie about the puller sticking out, we know that's not true as well, because as you see, all of my pullers are done up, torqued up with a spanner, and none of them are protruding out the side of the bearing. So 3 lies in a row.
The spacer was described as completely undamaged.
The reason it was described as undamaged is because I was telling the truth, something you seem incapable of doing, Hambini.
If you look at the screenshot, it looks as though the end is flared.
Well, you know what they say, looks can be deceiving. For example, before this video, you looked like a credible engineer.
You can see the light reflection here, so if you follow this line, it ticks up here.
Allow me to explain this visual phenomenon. This is an oily tube. It was oily when I removed it from the hub. You can also see the oil on my fingers, and that accentuates the reflectiveness of the tube. The reflection is always closest to the source of light being just above my desk. What the light is doing is it's following the high point of the tube, so that's that white line you see. But if you look slightly higher than the white line, you'll also see a black line, which is in reality the edge of the tube. If you follow that black line all the way up, it maintains a straight path. But if you follow the white line, it ticks up slightly at the end. The reason it does that is because it's following the curve of the tube once it reaches the top, because the curve of the tube is closer to the light source. That is why you have a beam of light traveling up the tube with a tick at the top. No other reason. But for those of you who doubt the veracity of my claims, here is the preload tube again for a second time after I pulled the bearing for a second time. So if the bearing puller were to cause damage, then you would most certainly see it now. However, I put it against as many straight edges as I possibly could, and I found absolutely no damage whatsoever, not so much as a scratch. So, I think this is fairly conclusive. As you can see, no flaring of the tube is present. And there it is on the axle, perfectly sound. And with that, there is only one thing left to do.
Yes! Yes! Oh, yeah! Can you feel that, buddy? Huh? 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 I have exorcised the demons. This house is clear. Get him out of here, loser! Let's go, Ace. Loser.
Thank you so much for watching, everybody. It's been a real pleasure. I will be making a follow-up video to this because there was a few things that I just simply couldn't include and the video was getting too long already. So click the notification bell if you want to be aware of that one when it drops. And I shall see you all really soon. Do ride safe, everybody.